Motion in vertical circle. When a body is moving in a vertical circle, to continue to be in the vertical circle, what are the minimum velocities it has to maintain at the top and at the bottom of its path? At the top, what is the minimum velocity is nothing but root of gr, where r is the radius of the circular path, g is acceleration due to gravity. Similarly, at the bottom of the circular path, the minimum velocity it should have is root of 5gr, where r is the radius of the path and g is the acceleration due to gravity. And this is proved by using a derivation, by using conservation of energy, and this is very important for doing some physics problems. So what are the minimum velocities? At the top is root gr, at the bottom is root 5gr. Now what are the examples in daily life? The merry-go-round, if you see, the minimum velocity to continue to be in a vertical circle is root of gr at the top and root of 5gr at the bottom of this circular path. Merry-go-round is example of this vertical circle. Here the speed breaker. On the top of the speed breaker, the maximum velocity of the vehicle should be having root gr. If it is more than that, what is happening is it won't be touching that surface. Simply from the top, it jumps from that place. So if the velocity of the vehicle is more than root gr at the top of this speed breaker or a speed bump or a hump, what is going to happen? The tire won't have the contact with that place and simply jumps from that place, which is not desirable. So these are the examples of this vertical circle, some of the examples of the vertical circle.
Well, this is very simple activity which demonstrates the importance of centripetal and centrifugal force. Centripetal force is a force which is acting towards the center, whereas centrifugal force is acting away from the center. These two forces, what we have learned is these two forces are equal and opposite. But we don't know whether they really are equal or exactly opposite or not. Now this activity will confirm the fact that these two forces are equal and they are opposite. Generally, when you rotate, this is the small pan, and then in this I have put a paper cup filled with water. When I rotate it in the vertical plane, when I don't do it properly, the water, generally whenever you invert a water glass at the vertical plane, water will fall down. But to our surprise, this water will be intact when I rotate this in the vertical plane. Let us observe whether this is going to happen or not. See now. See?